Hello and welcome to my channel. In this video, we have a fine exponential equation to solve. 2 to power x minus 2 to power y is equal to 1984, where x and y are members of the set of positive integers. What do we know about this question? We know that 2 to power x minus 2 to power y will give us a positive integer, which is an even number. In fact, 2 to power any positive integer is always even, as 2 to power x is even and 2 to power y is also even. We can also see from the equation that 2 to power x is greater than 2 to power y, and so x is greater than y. So for us to solve this problem, we need to let x equals to y plus a constant, where the constant is also a member of the set of positive integers. Now let us substitute y plus k for x in the original question. So we'll have 2y plus k minus 2 to power y is equal to 1984. If we apply the addition law of indices, which says a raised to power b multiply a raised to power c is equal to a raised to power b plus c. Here we are going to proceed. So if we apply this law here, we'll have 2 to power y multiplying 2 to power k minus 2 to power y is equal to 1984. Now let us factorize 2 to power y out. So 2 to power y bracket 2 to power k minus 1 is equal to 1984. Now we have got to a point where we now need to analyze the equation again. This is an even number and this is also an even number. The 2 to power k in the bracket is an even number, but this quantity 2 to power k minus 1 is an odd number. So this is even and this quantity is odd. That means that we have an even number here, which can be expressed as a product of even and odd number. So let's express 1984 as a product of even and odd number. For us to do that, we need to look for the prime factors of 1984. If we divide 1984 by 2, we'll have 992. Divide by 2 again, we have 496, because 992 divide by 2 we give us 496. If we divide this one by 2, we have 248. Yes, and then divide by 2 again, 124. Let's keep dividing by 2. This is 62, and then divide by 2, we have 31. We can't divide 31 by 2 because 31 is an odd number. If we divide 31 by 31, we'll have 0. So 1984 can be written as 2 to power 1, 2, 3, 4, 5, 6. 2 to power 6 multiplied by 31. Now let us go back to this equation, remove 1984 there and put 2 to power 6 times 31 in place of it. So we have 2 to power y, 2 to power k minus 1 is equal to 2 to power 6 times 31. We can now equate 2 to power y to 2 to power 6. Then from here, y is equal to 6. And if we equate 2 to power k minus 1 to 31, we have 2 to power k equals to 31 plus 1, giving us 2 to power k equals to 32. 32 can be expressed as 2 to power 5. So we have 2 to power k equals to 2 to power 5. And so k is equal to 5. We found the value of y to be 6 and k to be 5. Let's remember that x is equal to y plus k. Therefore, x is equal to 6 plus 5, which is 11. Let us back substitute the values of x and y into the original equation and see if we are going to get 1984. So I have 2 to power x minus 2 to power y equals to 1984. Now x is 11, so 2 to the power 11 minus 2 to the power y is 6, 2 to the power 6 is equal to 1984. 2 to the power 11 is 2048, and 2 to the power 6 is 64, equals to 1984. If we subtract this, we'll have 1984 equals to 1984. So our equation is balanced. X is equal to 11, y is equal to 6. So x comma y is equal to 11 comma 6.